Problem 2.4. For which numbers a, b, c, d, real numbers, in the reals, the function f equal to a times x plus b over c times x plus d, so a rational function, is its own inverse. That is, i.e., the f composed with f is the identity in the domain of f. Okay, so first, the domain of f is the reals. So let's see, the domain is the reals minus the values that make this denominator be 0, but in this case you can see it's minus d over c, right? That's the number. So yeah, that's the domain. Now for the problem, in order to find the inverse of f, so let's call this the inverse of f, is the function such that when you compose it with f, you get the identity. Okay, so in other words, f inverse composed with f of x is just x. Okay, so now we want the values of x, sorry, of a, b, c, and d that makes the inverse be the same function, which means that f composed with f is the identity, as it says. So we want the values that makes this be x. But what is f composed with? Let me erase everything. Okay. F composed with itself is just f of x, which is to say the same thing, but instead of writing x, we write f of x plus b, and then c f of x plus d. And then in f of x, we just plug the expression ax plus b, cx plus d plus b, and then cax plus b over cx plus d plus d. And then this is equal to x, okay? That's the condition we want. F composed with itself is equal to x. So we want to solve this equation and get find the conditions that we want. So let's expand these things. I'm going to say, okay, this is a squared times x plus ab plus bcx plus bd, and all of this over cx plus d. And then in the denominator is acx plus bc plus cdx plus d squared over cx plus d, okay, equal to x. Now assuming cx plus d is not 0, and we know it can't be 0 because f is not defined there, then we can just divide by cx plus d or multiply or whatever, cancel, and then we can multiply this thing in both sides, so we get a squared x plus ab plus bcx plus bd is equal to acx squared plus bcx plus cdx squared plus dx squared x. Okay, so let me get everything to the right hand side. So we have let me erase here. So we have now ac plus cd multiplying x squared, and then plus bc minus a squared, well, yeah, sorry, bcx and bcx go away, so we have d squared minus a squared times x, and then plus ab plus bd, or sorry, minus here, minus ab plus bce will equal to 0, okay? Now, in the left hand side we have a polynomial, second order polynomial, okay? X squared times something, x times something, independent term. This is equal to 0 for every value of x. So the only way to do this is to have the constant polynomial. So that means that every coefficient has to be 0. That means ac plus cd equals 0, a squared equals d squared, and then ab plus bd equals 0. Okay, so we need to fulfill these three conditions in order for f to be its own inverse. Okay, so now we can factor out c here, a plus d, and then we have a squared d squared, and factor out b, so we have a plus d. And so now, as you can see, for the first equation, in order for it to be 0, there are two possibilities. C is equal to 0, or a plus d is equal to 0. So let's start with C. Assume a plus d is not 0. So if a plus d is not 0, then b has to be 0. So b equals, let's say this is the first possibility. B equals C equals 0, and then a is d, or b equals c equals 0, and then a is minus d, okay? Because a squared and d squared, these are the two possibilities that you get, okay? Now the third possibility is if a equals minus d, okay? And so now c and b are free, and this second equation is fulfilled. So the function that we get, f1 here, so if you substitute here, we have b is 0, c is 0, and a is equal to d. So a is divided, what you have is x. That's the first function. And it's obvious that x, it's its own inverse. f2 is the same, b and c is 0, and a is minus d, so we have minus x. And finally, for a equals minus d, what you have is f3 is ax plus b over cx minus a. Okay, which is interesting that this function is its own inverse for every value of a, b, and c. But yeah, you can have a equal to, yeah, sorry, remember that the denominator cannot be 0, okay? And yeah, that's it.